algebra students. In today's notes, we are going to learn how to solve systems of equations by substitution. So this is still a linear system of equations. We have x and y. Our goal is going to be either to get x or y by itself. So we have x equals a number sentence or y equals something. And then we've seen the word substitute before. We've seen the word substitute when it comes to variables. It might say like substitute 2 for x, and that means you plug it in. This is the same thing with systems of equations. So if I have x equals something, I take that something and I plug it in for x. This allows me to solve for one of the variables and then plug that value in to solve for the second variable in the equation and get a solution to a system of equations. All right, so notice in this first example, both equations are y equals something. So what I'm going to do is I'm going to take what y equals, so in this case negative 4x, and I'm going to substitute it for y. So I'm going to write a new equation, but instead of writing y, I'm going to write negative 4x because I know negative 4x equals y. I'm going to say equals, and then I'm going to write the rest of the equation, negative 3x plus 14. Now I have an equation with just one variable x, and we know how to solve for one variable. We're going to combine like terms. I'm going to add 3x to this negative 4x. So now I have negative 1x equals 14. Divide by negative 1, and x equals negative 14. Now here's one of the tricky things with substitution. We got an answer, x equals negative 14. However, we are not done yet because remember, a solution to a system of equations has to be an ordered pair. I have to have an x and a y. This is only half of my answer. So what I do with that is I take x equals negative 14 and I plug it in for x to solve for y. So I'm going to go ahead and plug it into the second one. So I'm going to say y equals negative 4. Then I'm going to plug in negative 14 for x. And then we multiply. Negative 4 times negative 14, which is positive 56. So y equals 56. That means my solution, my ordered pair, is negative 14, comma 56. Remember, the solution is both pieces of the ordered pair. All right, in the next example, I have x equals 6y minus 7, and then 4x plus y is negative 3. Because in this equation, I already have x equals something, I'm going to take that something and I'm going to plug it in for x. I'm going to substitute it for x. So I'm going to rewrite this equation, but instead of writing the x, I'm going to substitute 6y minus 7. So I substituted this for the x. I'm rewriting that second equation. So now I have plus y equals negative 3. All right, now again, we have an equation with just one variable. We have y. We know how to solve an equation for one variable. We're going to distribute the 4. So 24y minus 28 plus y equals negative 3. Combine like terms. And continue to combine like terms. So I have 25y equals 25, which means y equals 1. Now again, this is half of my answer. This is half of my solution. So what I need to do is I need to take that value for y is 1, and plug it in to solve for x. Now, both of these equations look equally as simple to plug in and solve. So I'm just going to do the top one. It really doesn't matter. You can plug in 1 to the bottom one if you want. We're going to do x equals 6 times 1 minus 7. Well, 6 minus 7 is negative 1, so x equals negative 1. That means my solution is negative 1, comma 1. All right, so what's different in example 2 is that we're going to have to rearrange an equation to get a variable by itself. So in example A, I have negative x plus y equals 3. And I have 3x plus y is negative 1. Now in the first equation, I see a pretty easy step here I can do to get y by itself. So I'm going to rewrite that first equation. I'm going to add x to both sides, so I have y equals x plus 3. Remember, we cannot combine the x and the 3 because they're not like terms. So I just have y equals x plus 3. But now I have something that y equals that I can substitute for y. So I'm going to take this x plus 3, and then I'm going to substitute it for y in the second equation. So I'm going to rewrite the second equation, 3x plus, but then instead of writing y, I'm going to substitute x plus 3, and then finish the equation equals negative 1. All right, then we solve. I'm going to combine like terms. 4x plus 3 is negative 1, minus 3 from both sides. So 4x is negative 4. Divide by 4. X is negative 1. Again, this is half of our solution. Now we take that x equals negative 1 and we substitute it to solve for y. I'm going to use this equation since I already got y by itself. So I'm going to say y equals negative 1 plus 3. Negative 1 plus 3 is 2, so y equals 2. So my ordered pair is negative 1, 2. My solution is negative 1, comma 2. All right, same thing in this second example. It's a little different because we're going to have to rearrange an equation to get a variable by itself. I have x plus y equals negative 2, and I have negative 3x plus y equals 6. Now this top equation, I could rearrange for x or y. Because I see y by itself here, I'm going to rearrange for y. So I'm going to subtract x from both sides and rewrite this top equation as y equals negative x minus 2. So then I'm going to substitute this for y in the second equation, rewrite it, negative 3x plus negative x minus 2 equals 6. Then we solve for x. We're going to combine like terms. Negative 4x minus 2 is 6. Add 2 to both sides. So negative 4x is 8. Divide by negative 4. So x is negative 2. Again, this is half of my solution, so I'm going to plug in negative 2 for x. I'm just going to do it in this one here. So I have y equals, if it's negative x and I plug in negative 2, that means I have a negative negative, which cancels out. So it's now positive 2 minus 2, which is 0. So my ordered pair, my solution, is negative 2, comma 0. Now, anytime you're solving a system of equations and you get a solution, one thing you can do is you can plug in your solution back to both of these equations, and it should work for both of the equations. If your solution only works for one of the equations, it is not a solution to the system. So I can plug in x equals negative 2 and y equals 0 to both of these equations, and it'll work. So if I plug in, I'm going to do this in a different color so you can see. If I plug in negative 2 for x plus 0 for y, yep, that equals negative 2. We're good. And if I plug in negative 2 for x, 0 for y, negative 3 times negative 2 is positive 6. So yep, we're good. All right, last example, guys. A drama club earns $1,040 from a production. A total of 64 adult tickets and 132 student tickets are sold. An adult ticket costs twice as much as a student ticket. Write a system of linear equations that represents this situation. What is the price of each type of ticket? So first, we need to come up with two equations to represent this situation. The first one, I'm going to have to do with the cost and the total cost. So there's 64 adult tickets plus 132 student tickets and that totaled $1,040. And then the second equation, an adult ticket costs twice as much as a student ticket. So because in the second equation I already have A equals 2S, I'm going to substitute that 2S for A. So I'm going to rewrite my equation as 64, but instead of writing A, I'm going to write 2S plus 132S equals 1,040. Then we simplify, so 64 times 2 is going to be 128S plus 132S equals 1,040. Combine like terms. And then divide by 260 to get S equals 4. Now this means that the cost of a student ticket was $4. The question asked, what is the price of each type of ticket? So we know student cost $4. We still need to plug that in to find the adult ticket. The adult ticket costs twice as much as the student ticket, which means the adult ticket costs $8. All right, so in today's notes, you learned how to solve a system of equations using substitution. How is substitution different from graphing a system? Well, we learned yesterday in our notes that when we graph, so we have two lines, when we graph, the solution is the point where they cross. Now, when we're solving with substitution, if we were to graph those lines, the solution would still be where they cross. Substitution is different. It's just a different method. We're using the numbers, we're solving it algebraically instead of looking at a graph and finding the solution. But it is the same thing. If we were to graph the systems, they would be the same thing. Why do you need to solve for a variable when you use substitution to solve a system of linear equations? Well, that's the strategy. You solve for one variable so that you can plug it in and solve for the other one. Kind of hard to solve for two of them at once if you don't know what one of them is. So the reason we substitute is so that we can solve for just one variable. How would you substitute y equals 4x plus 5 into the equation 3x plus 2y equals 10? Well, this one is already set up where y equals 4x plus 5. So I would take that 4x plus 5 and I would substitute it for y. Why is it important to check the solutions? Well, we only did this with one example, but you should be able to plug in both x and y to both equations, and it should be true for both equations. If it's not true for both equations, it's not a solution.